My name is Nima Poladadi, and I'm a student at University of Miami, and I got my first PhD in my country, in Iran, but most of my work was based on the AI, and this is my second PhD. I'm working with Dr. Antonio Gani at University of Miami. Today we are going to talk about the machine learning approach for the flexural strengths of the 3D printed fiber reinforcement concrete, but based on the Meta-heuristic algorithm with the sensitive analysis. This is our team. We have two computer science guys and three civil engineers, and I'm both. And I want to make a bridge between the civil engineering and the computer science. At the first, I want to ask the audience, how many of you, work with the AI? If you can raise your hand. Okay. And how many of you, know coding? Okay. And how many of you, whenever you want to use the algorithm, you didn't just use the algorithm. You go and to find what is the algorithm, why this one, why not that one. Have you ever tried to find this? Okay, it's less. The most important part here is the novelty of this work is we create our own algorithm. We will not use XGBoost, we will not use the decision tree or other methods. The first I want to talk a little bit about the machine learning. Machine learning, as you know, is a type of the AI. It's not the AI, it's a type of the AI that enables machines to learn from the data and deliver predictive models. We have 7 steps of the machine learning. The first step, we need to gather data. The most important part, but unfortunately, even if when sometimes we get the data from the papers, it's not accurate. It happened to me a lot, and because of this, whenever I see some strange data, immediately I send an email to the authors. If I can contact with them, I will use the data. If I couldn't, I will never use that data. The second one is the preparing the data. The first one is the training, hyperparameter tuning. It's the most important part. Prediction, evaluation, choosing a model. These are all the steps of the machine learning. What is the difference in the machine learning and the old programming? In the machine learning, we have the data and we have the output. And then we use the machine learning to create a program. But for the traditional programming, we have the data and we have the program, and then we got the output. But how does the machine learning work? We should, at the first, define our objective, and after that, then we try to collect our data, the most important part. Because if you put the garbage if you feed the garbage as an input, you will get the garbage as output. This is the most important thing. After that, we should prepare the data. In the preparation of the data, sometimes we need to normalize the data, sometimes we don't need. And after that, we should select the algorithm, which algorithms are the best and suitable for our project. Second one, the next one is we should train our model, but not just 1 time, 2 times, 3 times, at least 30 times. And after that, we should test our model, and then we should evaluate our performance metrics, and then we can create a model. These are some machine learning algorithms that I know most of you know about these. Some of them used for the classification, and some of them for regression. Okay. We will start our journey from here, our methodology. First, there are so many algorithms. Which one is the best? Who knows the answer? Who can say the XGBoost, 3Boost, or others?
It depends on the requirement.
Nobody can say that my algorithm or the other algorithms is the best. Why? Because we will not give anybody free lunch. Because of the no free lunch theorem that Dr. Walpert with Macri did in 1997, they published a paper and they talk about this. And the most important thing that they mention is that there is no universal algorithm for all problems. Nobody can say that this algorithm is good, that algorithm is bad. For some models, some algorithms works very well, for the others, some won't. Why I'm going to use the NGO, Montagne-Ghazal Optimizer? Absolutely, you know that it's my algorithm, and because of this, I want to use it. No, I'm joking. Because we published this algorithm in 2022, and we got more than 143 citations, but the citation is not the matter. 118 applications were used from this algorithm. For the algorithm, you must prove that your algorithms work very well. But how? We have 25 benchmarks in mathematical. They have a lot of complexity. As you see the figures, some of them I mentioned there, they are so complex. You cannot solve it with the mathematical or other methods. You want to use the some approximation method. Meta-heuristic algorithms comes from the algorithm that we will not get the the exact solution. We are going to find the approximate solution, but this approximate solution is really good for us because we save the time, and if we save the time, we will save the cost. And because of this, if you see the some of these mathematical models here, you will see that we have a lot of local, and global. We have just one global, sometimes more, but most of them they have some algorithms they got to start in a local position, local optimization. And because of this, we should have an algorithm to find the global optimization. We test all these mathematical models on our algorithm, and we got a good solution. Okay, here's the interesting part. This is our friend, it's a Montagne-Ghazal. We got inspired our algorithm from the nature. Why? Because I believe that artificial intelligence is not artificial. It is a nature intelligence. I watched a lot of news about this kind of the animal, and I found out that in the nature we will have a different kind of animals that they follow some rules and they survive in the world. Some of them they we didn't know what happened to them and they disappear in the world. But some of them they are still alive and they live. But all of these algorithms they follow the rules between each other, and in each animals we have something like that. But Montagne-Ghazal, we choose this animal, and in the Montagne-Ghazal we have three different category. I mean that tribe. The first one is the territorial solitary males. The second one is maternity herds. The third one is a bachelor male herds. We are going to talk about each of them, and after that we will convert all these behavior in a mathematical formula, and then those mathematical formula will convert it to the codes in a Python format. Here, the theoretical solitary males that we mentioned it is when the Montagne-Ghazal, especially the male, they reach adult and become strong enough, they create a solitary territory and are highly territorial and create a distance separate the territories. When they got a mature, they create some tribe for themselves and they will not let the others to come in their tribe. This is the first one. We had the formula for that. These are the mathematical formula, and for random number we use the amplitude of the variable vectors variations. We have 4 different coefficients. The second one is the maternity herds. We know that in the maternity herds play essential role because of the the cycle of the Montagne-Ghazal is based on that. This is the second one. We change the formula for this. I'm not going into detail for the formula, but if you need after this meeting, I can talk about that. The third one is the bachelor mate, that they are the new male Ghazal nature, that they try to get the leadership of this tribe. And because of this, they want to possess the female, they want to get the female, and after that, they want to get the leadership position. Why we are looking for the leadership position? The leadership position here is our best solution. When somebody is powerful, he has the power and he has all things in his hand. And this is our best solution. But how? Sometimes you see that, we have some people that they have a power, but suddenly something happened and they lost their power. How? We call that mutation. In the mutation, we find some Ghazal that they can come and get the leadership. Why? Because they were, searching for the food, and suddenly they found out that, oh, this guy is a leader in this tribe. This is the last one. This is our flowchart in our algorithm. We initial some Ghazal. Our Ghazal is our population, and after that we set the iteration. Then we have a population. After that, each 4 categories that I mentioned, all of these create a new solution. All these are the numbers. We are working with the numbers. And after that, we create a new numbers and we put it in our population. If that number is better than the previous one, we will remove that and we will sort the population. And after that, the iteration, will keep going until we face with the criteria as a start. Okay, now we are going to use this algorithm for our application. In our application, we want to use for the 3D printing first because it is a novel concept to researcher and engineering. It reduces a lot of things about the labor expense and the time, the cost, everything is good for the 3D printing. And the 3D printing has some problems, but when we use the 3D printing, we believe that we can reduce the emission of the greenhouse in atmosphere. But the most important part here is that because the 3D printing is new and we have less data for that, and after that we don't have any formula to use because we have a non-linear connection between the different parameters, and sometimes we use some material inside the 3D printing, and it will be so complicated to test it. We can test it, but it's time consuming and it costs us a lot. Because of that, we are going to predict the 3D printing. These are our parameters that we have: the Portland cement, water, sand, fly ash, ground slag, silica film, and some others. And we are going to predict the flexural strengths of our models. But here we use some fiber inside the 3D printing. It's a PE, ST, PVE, PP, and basalt. The performance metrics. We will not use just one performance like a coefficient of determination. We should have at least 5 to show that our method works very well, an application. Residential error, coefficient of determination, mean square error, root mean square error, and mean absolute error. Okay, this is the flow chart for our model. At the first, we use our algorithms to train our model. Here we initial the population, then we evaluate our fitness. Our fitness here is MSE, one of the performance metrics, and after that it goes to our algorithm, and then we will return the best NNA with the minimum of the MSE, and after that we will find out our solution. These are the common things that you always see about the machine learning, that they show the correlation between the parameters and how our data distribution. Okay, this is the discussion. What is this figure? When we want to use the algorithm sometimes I see that we put a number in a Python or in a MATLAB that we use the same, train and test data. But I believe that it's not a good, we should change it simultaneously. And for this reason, we ran our algorithms for 30 times, and each time we gain the R-square for the train and the test. And if you see, in all of these 30 runs, our algorithms is more than 95, 96, 90% for both train and the test. And it shows that our algorithms work very well. And after that, we choose the best model here with R-square of 97 for the train and for the test, it's 96. And we are going to create our model based on this. This is our convergence curve that our algorithms started from, 25%, and after that it will be reduced, to our MSE, but with a 1,000 iteration. And when the convergence curves will be aligned, it shows that there is no change in our object. This is our score that we mentioned for the train, for the test, and for all of our data. Our MSE for all data is 0.0131, and our score is 96%, more than 96%. This graph shows that how our, predicted with the data are, cover each other, and how is the difference between them. For the test, for the train data, this is the for the test data, we had it, and this is the ordered bar plot. It shows that which parameters are important in our method, but this bar shows that based on our data. Because in our data sometimes, the amount of the cement, they are not different from each other. It shows that the sand and the F8 here is the most important part and in our data. But then, this is our formula that the engineers, they are going to use this. It's hard for the engineering, and I always believe that when I came to the ACI convention last year, it was the first time that we had a session. I see that a lot of scientists use the machine learning prediction models. They publish a lot of papers, okay. But then what is the benefit for the engineers? And then at those times, I come up with this idea that at each of these, papers, each of these models, first, you should share your data, okay? Sometimes we say that, oh, our data, we cannot, share it or something like that. But if you gain the data from the literature review, there is no need to hide your data. If the data is real, you can share it. If you got the data from the industrial, this is another part. But if you get the data from the literature review, it's so obvious that you can share the data. The second one is that how the people who are not the scientists they are not expert in the coding, how they can use this. We just publish a paper and we say that, okay, this is like that, and the people, the prediction of the flexural strength is that. No. At that time, I come up with this idea after each of the methods, we should publish the codes first. The second, we should publish the software. This is our software, it's free, and you can use this software. This is my website. You can go to the algorithm parts. All these algorithms were developed by myself. It's more than 20 algorithms that we publish it. And you can download the codes. And after that, this is the software that you can go and download it and you can use it so easy. Thank you very much for your attendance. And thank you for the NSF, for the central integration of the composite into infrastructure, and for my internship, FISM, and thank you for the University of Miami, and special thanks for all you attend to this session. Thank you very much.